This is some big brain stuff. This is like how you turn into like a wizard when it comes to these things. I mean, it's practically magic. Electronics are magic. I do it for like my day job, and don't get me wrong, every single day I'm more convinced that no electronics should ever work ever. Like, it's terrible. All right, so I was gonna do all this stuff on stream, but the internet's out. Man, I really hate AT&T like a lot. I want to show you some stuff that, I mean, is really helpful to help understand what pickups do, because it's certainly one thing to just look at a diagram and just match the diagram with what you're doing. But when you get custom pickups, right, and you get them in this box and it literally just gives you like a CVS receipt and expects you to do the rest of the work, I find it better to be smarter than the diagram. You are smarter than a piece of paper. You are smarter than a receipt. So I know there's certainly one philosophy in being able to just copy and do and be a technician, but there's another thing to be a designer and understand what's going on. So I want to get you on the second level because I found some very interesting things that I'm going to do with this. So first things first, this is a Fender Modern Player Stratocaster. It's from China, and you'll notice that we have an HSH pickup configuration, right? This is a little bit unique to Strats. Usually it's all single coils, and this is probably, you know, maybe even something around 2010 kind of a model era. If we go look online and you look up this kind of some of the Stratocaster stuff, you will find that this does not match what I have. For me, there's a lot here. All right, so we got ourselves, man, I just realized how filthy my mouse pad is. I'm gonna fix that. Okay, so what we got, what we got here, as you can see kind of in the diagram earlier, we've got, you know, these three pickups, the two humbuckers, and the single coil. You've got this mega mess of wires, which we call a super switcher, which is absolutely ridiculous. And then just like the diagram, we've got two tones here, and we have a volume. If I quickly switch back, if you notice the capacitor is supposed to be on the second tone knob. And you can tell the capacitor is actually down here on this other one. So we already know that the stuff that we have online doesn't match what we have. So we might as well just figure out what's wrong and what's good. So the first thing that really stood out to me is I don't know what in the world is going on with this switch. So when I flip it, it seems like you have something that's kind of crazy, and you have two of them, see the green here and the green there, stacked on top of each other. And it's really miracle that this guitar had it, because otherwise I wouldn't want to do, or I wouldn't have all the options to do all the crazy stuff that I wanted to do. Yeah, so how does the super switcher work? So if you notice when I'm moving the switch on the front of the guitar, you can see the mechanical things that move. So there's actually two tabs that are moving between these two sets of connections. And then you have these other tabs on the far left and right. See, those are always connected. You've got essentially connection between 5 different, well, leads, and then you've got one thing that goes out, and you have that multiplied by 4. So really you have 4 switches in one switch. That's kind of the benefit. So if I'm all the way here, this would be kind of the bridge pickup position. And then if I'm all the way over here, I'm in the neck positions. So that was the first hurdle. I have a video of this in more detail linked in the Grimoire, which I call the description box down below, and you can just go click on that and check out more if you want to learn more about this. But all I need to do is to break it out of the diagram and out of its physical form and more into what we call a schematic form, which we'll do in just a sec. Let's see what else is weird with this guitar. Okay, what do I have here now? Well, I've got pretty much this big bus of wire that essentially represents the pickups. All the wires to the pickups will come out of these. You notice for this middle one, I've got white, and actually for these other ones, we can't see them. So looking on the opposite end, we see that we actually have 3 wires coming out. We've got this black one, which seems to be ground. We have white and we have red. So now that we know what kind of wires we have coming out of the pickups, we know what we do and don't have in context of connections. One thing that absolutely confused me about the guitar is what happens with the pickups when you're in positions 2 and 4. So if this is 1, that's 2, middle's 3, then you have this in between for 4, and then you got 5. So there's a really easy way to test which pickups are being used, which ones are active, which ones aren't. I'm gonna take my little cable here, plug it into the guitar, and then using just a standard screwdriver, making sure that I have the volume and the tone and stuff all the way up, I can just lightly either tap or move the screwdriver near the pickups, and it will create sound. I mean, this is like a big, really thick string. Okay, so for example, let's see it in the 3rd position. We are dead in the middle of our switch, and we just need to figure out what is on, what happens when that middle pickup is on. So here I'm just like lightly tapping. You probably can't even hear it on my mic, but as soon as I tap the middle one, hear that? That's even waving in front of the pickups. I managed to get sound. So we know that despite tapping all the rest of them, none of those are on, and only the center pickup is on in the 3rd position. And then we just need to go through the rest of them. And so here's the middle one. This is probably the most important for me. So we know that in traditional 2 and 4 settings that the middle pickup is going to be used in some way. And it is. Clearly when we're in the pointing towards the neck, we're not doing anything, but, well, which one will be active? That's the big question. And so in this middle position, so we got the middle, and then doesn't seem like the bottom one's active, and definitely the top one is. Yes, I know it's crude, but my MS Paint skills are hard at work here. But we still need to figure out more of the full diagram. Where does stuff go? How do we figure it out from the schematic views? So let's build that. Before we get into what the whole diagram looks like, I think it's smart to break down an idealized version of the guitar almost. So we've got ourselves the most simple version of the guitar here. We literally have one set of pickups. We don't even have a volume knob. We don't have a tone knob. We don't have switches. We don't have anything. It goes straight then to the input jack. It's kind of funny that it's named the input jack, but I would actually more accurately call it the output jack. Okay, so why is it shown like this? What does the symbol look like this? So for that, we need to take a look at a guitar cable. We can see that there's 2 almost spaces for metal in the guitar. And the top one, this has this like a little tip, and then you see like the black that's separating the metal down here. So really we have the tip, which is actually holding your guitar signal. And then we have the sleeve over here, which is ground or return, or the triangle in my diagram. Sometimes it's represented as 3 little lines. So you see how that might be able to represent, right? You've got the jack that looks like a little sleeve that would hug around the middle part of the cable, and then you have this little straight line with a little indent which would then touch the tip of the guitar cable. So that's why it's written like that. And we have ground over here as the triangle, and we have the signal which goes to and from the pickup as we discussed earlier. So then we've got our hamburgers now. Our hamburger pickups, our humbuckers, and we've got that wire that goes straight from there to the input jack. I have some other stuff, some other things that are also connected to the input jack, like ground. Maybe there's like a back plate on your guitar. Maybe you have a trim system or a bridge wire. All this stuff all comes back and connects to that little rectangle, or to that sleeve, essentially. So what if we wanted to add a little bit more functionality? Okay, so now we have now added just a little bit functionality. We've added essentially a volume knob, right? So it looks pretty much exactly the same. We've got the line that comes from, or the wire that comes from the pickups, and instead of going straight to the input jack, it goes through this weird circle thing. You might recognize this as a pot or a potentiometer, and let me just talk a little bit about the way how it works. So what you're doing when you're playing around with the potentiometer, putting it at max volume, you're essentially saying, I want to move this line. I want to move it so it's actually only on one side, right? And if we're pretending that this one over here goes to directly to the pickup, we've essentially just bypassed all of this resistance. We've connected directly to one place, and that one place is directly to the input jack. Just ignore the capacitor for now. We'll talk about that. We might talk about that later. It was just more of a concept I left in from my actual diagram. And so what happens when you're moving the wire the other way, right? You're essentially saying, actually, I want to put it on this. I want this to connect on the direct opposite side. So, right, what's on the opposite side? Ground. Return. Nothing. The signal that's going on the input jack and your tip is essentially the same, and the speaker's not going to notice anything. Things need to change between the sleeve or ground and the tip or signal. They need to move around, but if they're exactly the same, then nothing, whether it be an amp, a speaker, or anything, nothing, it doesn't discern any difference. So you might have also run into some problems when you've been wiring up your guitar and you get maybe in one switching signal, or maybe some wires become loose and all of a sudden you get no sound out of the guitar. This is what's happening. You're essentially saying, hey, either nothing's connected to the input jack at all, the tip, or some ground wire or some ground connection is being made between the tip and the sleeve, maybe just somewhere else inside the guitar. Okay, so now we need to make things a little bit more complex again. Imagine if we wanted to now be able to control the tone of the guitar. So we have something else that we can add to the circuit. You'll have to excuse my really wide drawing as soon as I drawing as soon as we add everything in, it'll hopefully all make a lot more sense. Like we said before, if we're going to take this and we're going to move the slider around when we turn the knob, we're going to either put a lot of essentially resistance between this cap to ground, or we put a little bit. And right when we have this essentially is ignored because it's just hanging out. So it's just a little bit, or we're going to put no resistance in between the cap to ground. So this is like our line that's going to go out to the input jack and to the pickups and all that sort of stuff. So you don't really need to know this. This is called a low pass filter is what we're creating. And when we put no resistance in between the input jack and the capacitor, we're effectively not low passing the signal, or we're not filtering the signal at all. So when you're turning the tone knob all the way up, this is what you're doing. You're essentially saying, I just want the guitar signal. As some of you who are a little bit more astute might imagine, there's actual resistance within the cable itself, and so we might actually have a little bit of a low pass filter, but not much. So it's practically negligible. Okay, so now we can control tone. We can have a single pickup. We can control the volume. Now what? Okay, now we're getting even more crazy. We've got another set of pickups. So we had the one down here. Now we have the one up top. And we have this thing in the center, which is going to act as our switch. Right now it's acting as a 5-way switch, but we'll talk about that in just a second. So, okay, what are we saying here with this? So this is the switch. This arrow means that we can switch between any of these 5 contact points. Right now they're all connected together. If it was a bit smarter, I'd be, erasing them and making them single lines or something like that. So what we're doing is we're saying, well, this line can connect either to this spot, which we'll call position 5, then 4, 3, 2, and 1. You might know a little bit more about the actual mechanical parts of switches. In fact, so the actual mechanical properties between each of these, right, might actually have separate spaces and different orientations. Your switch might be different than mine. So this is kind of what you traditionally use for this kind of diagram. Okay, so we have our 5-way switch, position 5. We're actually going to connect the output of this top pickup or the neck pickup straight, following the line down over to the input jack. We go to switches 2, 3, and 4, 3, and 2. Actually, it doesn't connect to anything, so you won't get any sound coming out of the guitar at all. There's no pickups that are directly connected to the input jack. And finally, in the last position, position 1, we'll actually connect this bottom pickup, which we've decided is the bridge pickup, and then we will have some connection here. So really, what we're trying to say is that you can make these switches whatever you want. If you literally wanted a dead switch, you absolutely could. But let's actually make some use of this 5-way switch. Let's do something a little bit more interesting. If we wanted to connect both of these pickups to be on or active at the same time, I mean, you just do that. If all 3 of these are connected to each other, we see that when one switch is on, it's only connecting the bottom. When you're in positions 2, 3, and 4, you're connecting both pickups to be on and output straight to the input jack. Or when you're in position 5, you have this only the neck pickup going. This is essentially a really crude 3-way switch, right? If the switching between these 3 don't do anything, it's the same as one area, and then you've got the 2 opposite ends of the switch doing something more interesting. But let's throw more pickups into the mix and then let's see what happens. Okay, now I've taken you onto our final form here, so to speak, and we're upping the complexity quite a bit. So please, let's dig into it. So now we have what seems to be 4 switches. We have 3 pickups total, and we actually have 2 tone knobs. Let's dig into each one. So we're assuming that because of our crazy super switch, when we switch one position, all of the rest of the switches are going to switch to the same position. So you're always, if everyone's in position 5, every single one of these switches in position 5. So let's take a look at that. Again, position 5 here. We've got, well, it would help if there was a connection there. Okay, much better. So now if we're in position 5, this one would say, okay, we were going to actually use this top pickup and we're going to turn it on. That's the neck. Okay, how about position 5 up here? Connected to nothing. Cool, so it doesn't contribute at all. How about this one? Well, this one also doesn't contribute anything. It's not connected. Okay, fine. But then we get up to here, position 5, and we notice that it does connect to another potentiometer. So we've got ourselves a full functioning tone knob. So I have added essentially coils, or a symbol for a little inductor looking thing, in my schematic view. There's a lot of other stuff like DC resistance and other things that I could more accurately model this. I don't care. I could even just have drawn a wire and it would have been fine. But I'm trying to show that with every pickup, you could have at maximum, well, sorry, there's one more. There we go. You at maximum could have 5 wires coming out of your pickups if you have a humbucker. So why is that? Well, each rectangle is actually representing a different coil. Hopefully that makes a little bit of sense. We know that if we're essentially stacking 2 single coils on top of each other and making them really close, then we have a humbucker design. And this is kind of what this is trying to show. The reason why I said you have a maximum of 5, you have this wire that's meant to be connected to ground. Think of like, again, maybe has like a back plate on the back of the pickup or something like that. And really the way that it's been explained in every diagram that I've seen, you have something called the start of the coil, which is usually on the outside of the humbucker. And then you have something called the finish of the coil. And that's usually represented on the inside. The CVS receipt does explain this. Let me show you what I mean. So as you can tell, actually, you've got 5 wires. You've got red, black, and white. Those are 2 are going to be your finish. And then you have the green, which is the start of the other one, and there's also a bare, or a bare wire. I actually have the pickup here. Let me just show you what I mean. So you should be able to see now that we have 5 wires coming out of this pickup. So you can see one's really shiny, that's the bare one, that's the one we're going to use for ground. And as mentioned earlier, the red and green are the start of the top and the bottom coil. Then you have the black and the white wire, which represents the finish. The reason why I'm saying this is because you can actually change these wires around and flip them around and get some really interesting results. Okay, so we got positions 2 and 4 to worry about. We know that these switches control, or these connections for the switches control the tone, so we're not going to look at them. We essentially have positions 2 and 4. So if we're position 4 here, position 4 will be connected to the middle pickup, just as is shown here. And then on the other switch, we have the connection on number 4. There is something there. It's not floating. There is something connected to it. So we follow it. And then it takes us to this middle connection of the pickup. So how are we supposed to interpret this? Well, we need some sort of pathway to ground in order for the coil to work. If we look at this part of our coil, we follow it, we go through the wiggly part, and we're following it. It goes to this switch. There's nothing connected here though. We're connected to switch to position 4. So if there's nothing connected, it's just hanging out. The coil is essentially inactive. It's not being used. So if we follow this instead down and around to this pickup, this topmost part of the neck pickup is now on, inactive, and so is the middle. If we quickly look at our diagram, we can see that position 4 does activate the outermost pickup and the middle one. And in fact, we tested that with the screwdriver knot, but just a little long ago. So everything's checking out. So this is where it gets kind of interesting. So if we wanted to, we could erase the little wire that was once connected to position 1 up here on this switch. What if we just connected it directly to here instead? Okay, going through our same logic, we only know that this wire is only really active at position 1. Position 2, I mean, there is a connection, another wire coming from it, but it doesn't go anywhere. We're not connected here. So this is practically an inactive path. But this one is connected directly to the input jack, or output jack. Could call it I/O. It's connected directly to the jack and has a path to ground. We've just created a single coil out of a humbucker. And this is the concept of coil splitting, and it's what makes this one very interesting, because I have the option to not only make this a humbucker, I can split it and make it a split coil, or I can change it and I can invert the phase, I can put stuff in parallel. This is the power of having access to all the wires. And this is where the next question is, well, hey, my pickup only has 3 wires coming out of it. So you might actually recall that we only have 3 wires coming out of the pickup that's within this guitar. We only have a black, a red, and a white. And hey, guess what? This one's the black, this one's the white, and actually the one over here is the red. Essentially these two, the one that would be the start of this other coil, is connected internally. So they don't give access to all of the wires, and in fact they connect these two together. Sometimes the pickup is just not really, I don't know, designed to have all of these options, but some of them are. Some of them will actually not give this split and only give maybe even just 2 wires out, a ground connection and the one leading up to your pickup. It's giving less options, which makes it easier for you and for whoever's building the guitar to wire it, but it gives you a lot less option of what you can do with it. This is some big brain stuff. This is like how you turn into like a wizard when it comes to these things. I mean, it's practically magic. Electronics are magic. I do it for like my day job, and don't get me wrong, every single day I'm more convinced that no electronics should ever work ever. Like, it's terrible. So what am I gonna do with this guitar? Well, I've got the Dual Sound DiMarzio pickup here, and it comes with actually this potentiometer that has a push-pull on it. Ooh, fancy. And to kind of explain what this is, it's one component as far as you can tell, but in reality, they're two different components. One is the wiper or the knob that you've seen millions of times, and then you have on the back end also some switch connections. Okay, so this is how it works. So I have the potentiometer here, but like I essentially have two-way switches built into one. So again, if we're saying that up towards the top is when the potentiometer is pulled out, that means the switch goes there, and this other part of the switch goes up to the top as well. And then if you push it, it goes down to the other connections on the other side. All right, so here's how we're gonna go crazy. We essentially have two states, right? When the guitar, we can now interact with the guitar because we have the 5 wires of the DiMarzio Dual Sound pickup, and we have the push-pull pot. The push-pull pot is going to determine the two states that the guitar is in. So when it's pushed, it's going to be one thing. When it's pulled, it's going to be another. And I've outlined these as a result. To start, we've got the pushed, and I'll at least acknowledge that the top 2 pickup orientations, the switch selection is going to be the same. I didn't change those 2 pickups. They're going to remain the same. That's fine. The interesting bit is when we get down to position 3. So I actually hate the middle pickup sound by itself. It's really weird. I really can't find a fun and interesting use for it. You know, it's like I'd rather just have a pedal if I want to get that kind of sound. So I'm going to do an outside split, which is kind of a more extreme version of positions 2 and 3. And it'll be really interesting sounding. I'm really excited to hear how it sounds. And then as we get down, position 2 will be just the same as the as this guitar is. And then we'll have humbucker state. So very similar to what it originally is when the pot is pushed down. But when the pot is pulled, that is when I finally can get my split coil sound or single coil sound on the bridge pickup setting, which is kind of the main purpose for me buying the thing. And then I will actually have this 2 interesting, you could say, orientations. So 2 and 3, I'll actually have swapped the wire inputs and outputs, and we're essentially going to have them out of phase from each other. So we're no longer going to get the kind of humbucking or canceling effect from that you would expect by having 2 pickups on at the same time, but it's going to create some really cool sounds and results. At least I hope so. They might just be worthless, but there's only one way to find out. And then I'm just going to take you through one of the examples of how this works. If I were to do it, I'd almost split this kind of in middle and say, okay, let's just take a look at the top half and then let's take a look at the bottom half individually. So in the pushed position, which is down, we're going to have the black and white wires of the Dual Sound DiMarzio pickup in the second position, and then we're going to connect green to ground. Okay, let's just see what happens. So black and white, they're going to go to position 2, pretty standard, and then we're going to have green connected to ground. So in position 1, we've got this on, we have the path here, red goes through the coils, these 2 then feed it back into itself, and green has a connection to ground. It's the same thing as we talked about in the original wiring. Okay, cool. And let's take a look at the other state. So the other state is how we're going to get the split coil sound. So instead of being pushed, we'll be looking at the top half in the pull position, and we're going to have ground actually connected to those black and white wires, and then green is going to be moved over to position 2. So let's again take a look at our pickup area where we've got position 1 in the switch. We're pulled, so we know that black and white are connected to ground. So we'll have this be turned on, and then this green, even though I said it goes to position 2, it's not connected to position 1, therefore it's not contributing, it's floating, it's not doing anything that actually connects to the input jack. Only position 1 does, so it's ignored essentially, and we've got a path from red to black, and only this top north coil will be turned on. So that will that's how we get our split coil sound as an example. Okay, with that in mind, we need to get into the garage now. We need to start soldering this stuff. Name of the game, let's get rid of the stuff we don't need and keep, or at least set up anything that we need to reuse. So I'm going to take the pickups out of the pick guard, specifically focusing on the bridge pickup here. So there's the red wire. We know we'll need or we'll have a white wire as well as a black wire. And all of those connect to the pickup. It's pretty easy to identify and just get rid of them. We don't need them. And of course, we got to get rid of that black wire, which is the ground. It always feels weird to clip it off. So the yellow wire here, or the middle pickup, is completely bridged across the middle positions, which we expect. But since we have a different pickup wiring configuration, we're gonna change that. Here we're just getting the solder wick and cleaning up our old solder, and also prepping the new connections we're gonna make with just some solder here. You always know you have a good solder joint when it's shiny. And there we go. We get to repurpose the middle pickup. I then opted to have this kind of stretchy bridge wire, which you'll see me kind of fiddle around with, because I didn't want to have it exclusively in the middle position anymore. So that's why I do that. Here I'm just pointing out which one's going to be the top and which one's going to be the bottom, so we need to make sure we screw it in the right way. And hiding underneath, you know, insulated wire is, of course, more wire. If you didn't know you could do this, you can just make wires longer by doing that. Not actually longer, but you get what I mean. At least I think you do. Let's get that potentiometer out. We know, again, we're going to get rid of it. We're going to use the push-pull, so we need to uninstall that and install the new one. Here you can see it actually installed, and the other one's just kind of hanging off. We need to desolder all that and start soldering back onto the push-pull. I always love it when the angles are a little bit weird. Sometimes, you know, your tweezers aren't always your best friend, and you just need a big old thing of pliers, because that'll happen. So we're going to reuse the cap. It's actually almost bent in the same ways that we need to, and we need to solder it to one lead of the potentiometer and have it to ground, so I'm just going to do that to the actual base of the potentiometer itself. And of course we need to attach the other tone knob, so we'll do that here. And really, I'd say that soldering to a potentiometer is the thing that makes the most sense to me, honestly. But as soon as you start to get into this intricate stuff with the switcher, it's quite a lot. I sort of regret the size gauge of the wire. If I remember, I'll try to put it somewhere, but you couldn't really go with a thinner wire gauge here. It was kind of too thick to really be malleable. And I love using different wire colors here just to figure out what we're talking about. So I have the switch positions that eventually go to the push-pull. So we're just gonna double check that I actually know what's going on with the push-pull. Yep, both sides are connected to each other. It showed 0.1 or 0.01 or 0, so I know that they're electrically connected, which is great. And you can see that I moved the pickup selector all the way to that push-pull. And because it's the same kind of connection, I wanted to keep the color the same, and I just put that next to each other. People talk a lot about, hey, don't run the wires through the holes and then solder to them. it's a pain for rework, but I haven't really experienced this. It gives better mechanical strength, and I can just use the solder wick to pick up all the solder. It's really not a problem. And we'll check if the ground connection is actually secured to the case. And since it says 0.1 or 0.1 there on the dial, then I know we're good. And because we know it's connected to ground, I can connect it in the same place. And we'll just clean up the rest of the ground connections in the guitar. Simple as. Okay, now we're gonna continue on with the rest of our actual bridge pickup that we now screwed in and installed off screen, and we're wiring those to the push-pull as well. There's some prep work there as well when I said I'm going to tie black and white together. I did that, soldered them so I can easily attach them to the other lead, or essentially later. And let's check. I'm really gonna let the sounds, and it almost sounds like a DJ, scratch in a way, speak for itself. But I'm just gonna check them all here. Check it with the push and with the pull. You might hear some other tapping as well. This is a different mic setup, so you might hear a little bit more noise than you were beforehand. And the split's good. Definitely one of the few times I think that the wiring was perfect the first time. It happens very rarely on a project, but we take what we can get here. And we're good. Finishing touches, actually putting it in. You know, I heard that some of these push-pull potentiometers actually don't fit in some of the cavities depending on the thickness of the guitar. So that would be something to verify first before buying a whole kit like this. And with that, clean it up, put some new strings on, and I think we're ready for a sound test now. What do you guys say? Hello. This is my tiny beard jump scare, completely different room. I have moved. It has been a year from now. I have played around with the guitar quite a bit, still have it, still love it. And I had another idea of another mod. I think I'm going to do that in another video, but I've given this enough thought and enough time that I think I'm pretty happy with the way it turned out, even just immediately. So, I don't know. Let's play something and see if you agree. Oh, great. Oh, sounds so good. Yeah, so as you can see, rocks sounds awesome. I love it with the crunch tone. And anytime you break it up with clean, you can really, really hear some of those other tones that go through. Like even the split is different than, you know, your neck and middle kind of split or something like that. They both have different textures, and it sounds really, really good. I will say the only thing that's kind of unusable about this is doing the bridge and middles. So position 2 and then doing that for the parallel. You can hear the buzz. It's quite bad. And it sounds like a weird compressed intro, you know. That you would play before actually playing a song. So thank you for coming along with the journey. I absolutely recommend modding the guitar the way that you want, especially if you have an HSH. That middle pickup really kind of sucks. Get rid of it. Do something else with it. If you hopefully have the pickups to split it up and do things in parallel, do things in series, do things out of phase, I highly recommend that you do. And hopefully this has helped you just a little bit appreciate some of the wiring that goes into a guitar and how complicated it can be if you get something really, really custom. But in another way, it is easy, and I know you can do it. And hopefully you just look at something like this, and even if you just end up copying the diagram, it should give you the confidence to just experiment and do it the way that you want to do it. I'll catch you on the next one. Thanks for joining me, my guitarcanists. I'll see you next time. Peace.